I hope you enjoyed the keynote this morning. I hope you're happy to be here. I am, though. For our first conference today, we will have Nathalie Godek for a presentation about security in the cloud. She's a cloud architect, and she's a Google dev expert in cloud. She's coming from London for you, and she will talk about GKE in cloud. Thank you. Please welcome her.
Hello, everyone. Hi. Okay, we can go ahead. Welcome to the first session of the day after the keynote. I hope you all enjoyed the keynote. First question, is everyone okay with English? Yes? Perfect. Otherwise, I would have improvised it in French, which would have been a double improvisation because 12 hours ago, I had no plans to be on this stage today. And now I am. And how wonderful is that? Who am I and why am I talking to you about security in Kubernetes and all of the cool things that we can do in the cloud? I am Nathalie Godek. I'm a cloud/platform/system/DevOps engineer turned cloud architect. I build platforms in the cloud. I love how it sounds in French. Je suis architecte du nuage. But I build platforms for other people. I work for Zencore, a company that is a partner of Google Cloud. So what we do is we go to other companies and they say, hey, we need to have this platform and we want to do this with our data and we want to do ML and AI, of course, obviously. And we build the platforms for them to enable them to do their thing. My things are infrastructure, data, and security, hence why today I'm here talking about infrastructure and security. And you can scan the QR code to follow me on social media if you want to chat afterwards. And don't hesitate to tweet at me after this talk. So, point of view, what are we talking about? We're talking about needing to release something in a corporate environment, okay? What happens? Raise your hand if you work in a corporate environment, like a big enterprise. So you will know very well what happens next. This is a change, an example change. We have one line. This is not the exact change that I had to do the first time I joined an enterprise, a big corporate bank, but it was very similar. I was changing the timings of a cron job, I think. One-liner, right? Easy. Okay? You change, you do your changes, you test them on your laptop, you test them in dev. Cool. Now you need to request to release it into production. What happens? Well, the QA team needs to have a look, of course, test it. Then you have a change review council. You need to tell people why you need to release this change into production. Then you need to talk to the security team. They need to have a look and figure out whether or not this change is good. You need to talk to compliance, because of course, we need to be compliant. There's probably a second change review council. You need to talk to your doctor, go see a priest, and then eventually the ops team will pick it up and release it. I did not understand why we need to spend 2 weeks talking about a one-line change. And yes, of course, that's a very simplified example, but it happens for all of the changes. Why? Why do we need all of these processes? It matters because software supply chain security matters. What is software supply chain? Like a normal supply chain, we're building artifacts and things that are granted, virtual, granted code, but we still have the supply chain. So all modern software is built like this. When you release or build your source code, first of all, you are a human and you're prone to errors, and you might use something that opens up a vulnerability. So that is already a reason to be careful about your code. Then when you build it and you pull up all of the dependencies, all of those dependencies also go through the same cycle. So they are also vulnerable, potentially. And also they can be injected with vulnerabilities. Then you package the code. The CI/CD that packages the code into a runnable artifact can also be vulnerable. You can also inject things there. And then when you deploy, what if you didn't deploy the same thing that you intended to deploy? All of these things, all of the software that is run in the world today goes through the same process. And it's because of the dependencies specifically that we need to worry about the supply chain, and we need to worry about what we build and what we release in production. That's why you need to see 2 security councils and a doctor and a priest before you can release to production. I think 80% of the code, of the programs, of the software that is run worldwide today is vulnerable. And one of the examples of that, very well-known example of that, is the XZ outbreak, the SSH vulnerability. And this is a particularly interesting one because the attack didn't start when the vulnerability was happening. The attack started a few years before that. That these developers, because the packages for XZ, for SSH, a lot of it is open source, anyone can contribute. So the developers behind the attack, they started contributing to the package, to the source code, way before, a couple of years before. They started with like changing some stuff, cleaning up some code, cleaning up some comments, adding a testing library, and then modifying the testing library, and eventually adding a vulnerability, a huge vulnerability, to this package. And the only reason it was noticed was because someone noticed that their SSH connection was taking too much CPU or too much time. I don't remember exactly, but like a small little thing that someone noticed. And this attack is a supply chain attack. XZ is something that is used in SSH, so the dependency of SSH was compromised. And it took years. And how do we deal with that? That is kind of scary. Like, all of you use libraries and dependencies and all of the things that you just pull from open source, pull from the internet, base your Docker image on something. You use a bunch of Python stuff, a bunch of frameworks. What if each and every one of them is compromised? That's something that we need to think about, and that's why the software supply chain security matters. But what do we do? Well, in the enterprise, there has been a lot of work done to generate requirements that help combat this thing. So one of them is verifiable signatures on approvals. So that means that each step of the release approval cycle has to be verifiable. That's why in big banks you have change release councils, you have 30 people sitting on a call listening to every change, and then listening to someone approve it. But we can do it better. Another thing is separation of environments. That's why we separate environments. We test in dev, in staging, in pre-prod, and then only then we go to production. That is like a firm requirement, and the harder you go into the enterprise, or the more regulated the industry you're in, the harder this requirement is going to be. Up to the fact that your logs have to be split, for example, up to the fact that your access controls are separate. Everything needs to be separate and physically separated. Supply chain security needs to be enforced, and that's, again, why big enterprises have mirrors of the public registries. We can't use Docker Hub, for example, etc. Google Cloud has a mirror of popular registries so that it's scanned for you, and you can know that the things that you're using in your environment have been scanned for security and for known vulnerabilities. And another interesting thing is how you track that your deployment has gone through dev and maybe other environments and then to prod. That's a tricky one, and we're going to see how we can do it. The key is to automate everything, and we have tools for that. I'm going to be giving examples of specifically tools on Google Cloud, but it's the same idea with open source. You can use, I'm going to talk about GKE, you can use normal Kubernetes or whatever Kubernetes that you use. I'm going to be talking about GitHub Actions, you can use Cloud Build on Google Cloud, you can use any other CI/CD. I'm going to be talking about binary authorization. You can use an encryption algorithm of your choice. But the key is to automate. And the vision and the example that I'm going to use is a project that I've done for a UK-based fintech startup. So we're talking fintech, we're talking UK, we're talking governance, regulations, laws, legal stuff. But the CTO of this startup had a very clear vision. He wanted to use GKE, so managed Kubernetes on Google Cloud. And we suggested Autopilot, because Autopilot is even more managed than managed. And it comes with predefined security practices, which is really handy. You don't need to worry about whether or not you have secured your infrastructure properly. It comes already secured. GitHub Actions as one of the most used CI/CD tools, and it's really easy. You push your code, you write your pipelines, you write templates. Everyone is familiar with it, or at least familiar with another tool where the knowledge is easily translated into GitHub Actions. And binary authorization, which is the queen of this whole idea, of this whole vision. We're going to be cryptographically signing every step of the pipeline. We're going to be generating artifacts that cannot be tampered with, that are separate from the entire software development lifecycle, to verify that every single package running in production has gone through the proper process. And you no longer need to sit on that call with 30 people. You can have a pipeline in GitHub Actions. How? Let's see how. This is a very simplified architecture of what was built. You have prod and dev, and an orchestration layer in between. The orchestration was another GCP project, a bunch of them, where we managed things like workload identity federation for the authentication of GitHub Actions. We managed the log storage there, separated that between environments. And also there was an orchestration Kubernetes cluster that was dealing with things like Terraform applies and so on. In each of the environments, dev and prod, we have 2 clusters. And that is another thing that banks and finance like to do. We are separating the most secure, the most sensitive workloads and putting them into a separate compute runtime. So we have services that everyone can deploy in a sort of shared or regular cluster. And we have super sensitive banking, finance, core workloads that are running in a different cluster. Technically, they are protected in the same way, but this core cluster can have more controls around it, which is what we did. The layered security approach, the defense in depth, comes with a couple of things. One is environment isolation. Like I'm saying, you can see 2 very isolated environments with various things around them. They each have audit logs. They each have VPC service controls, which is like a firewall for your cloud APIs on Google Cloud. You do know that cloud APIs are public internet-facing endpoints, so we need to secure them. And everything is completely separate. Logs are separate. Access is separate, and so on. Binary authorization, which is a service that will, when you give it an artifact, scan this artifact. You can have policies where you define that this artifact shall not have vulnerabilities or shall not have more than 3 medium-sized vulnerabilities. And then you generate a cryptographic signature, which is stored in a cloud artifact called a note, and it's cryptographically signed. And if you deal with your access controls correctly, nobody can tamper with it. Which, like normally, OK, this is a very specific security tool. We're not going to give anyone access to edit it or to delete signatures. And you can specifically tell different runtimes. So for this case, for Google Cloud, you will have Kubernetes and Cloud Run as your main kind of container runtime platforms. And you can configure both of them to use binary authorization to deny deployment of any artifact that doesn't have a signature. And the last thing is the centralized artifact registry, which is an interesting one because usually, like, you can have a registry per project. You can have a registry per environment, and it's kind of easy to do. It's just there. You enable it. You push images. But we need to follow each artifact from dev through to prod, through all of the pipelines, through all of the steps and approval processes, and we need to be able to verify that what is running in production has been tested in dev. It's tricky, because how do you do that? Well, you do that with a centralized registry. And you do that with not rebuilding the images in your CI/CD in pipelines. You build it once, and then you add layered signatures of binary authorization to it. This is very valuable for finance, for regulations, for anything that might have audit, like a company that might have auditors come in and check on their infra and on their deployments. I've had many auditors come and ask, how did this end up in prod? And you're like, okay, we did this and this and this, and this is the pipeline, and this is the Jira ticket, and this is the signature. Cool. You can automate that process and just show them that this is the release pipeline. Here are the signatures. It goes through each approval step. Cool. Everything in that environment was private, of course. We have private GKE clusters. So again, GKE is a cloud service. It's a cloud API. Therefore, you can have a public internet-facing endpoint of the GKE. Not in this case. The control plane is private. The node pools are private. The networks are all private. We're using VPC peering when we need to communicate with the orchestration layer, orchestration cluster. And we're using things like NAT gateways, IAP, identity-aware proxy, for user access, private service connect for other cloud accesses. Because what happens in the cloud? All of these different services, even if they run in your VPC, not all of them will run in your VPC. So the Kubernetes control plane is not actually within your network. It will run in a separate network, like a one you don't see. Databases, they will have an endpoint in your subnet, but they will not actually run in your subnet. There is infrastructure that needs to be managed behind the scenes, and that will run in a separate network. That is Google Cloud Managed, or AWS Managed, or Azure Managed, whatever. Private Service Connect allows you to connect all of those cloud services and ensure that the communication stays within the Google backbone. AWS has equivalent services. We can configure them. Otherwise, you can have a situation where your private compute runtime is communicating to, I don't know, a storage bucket. That request goes out to the internet and then back into the cloud. We don't want that in a private environment. So we use services that allow us to make sure that that communication is fully private. And VPC service controls, which, like I said, is a kind of firewall for your cloud APIs. It allows you to filter different requests coming into your cloud environment. It is kind of hardcore, because once you enable it, you deny everything. And you need to filter what is allowed. And in an environment with multiple running parties and different clusters and so on, it's kind of tricky. But it ensures that your data cannot be exfiltrated, which is super important as well. And another very important thing is the developer experience. I've been talking about the setup and how everything is private and how we cryptographically encrypt all of the artifacts. OK, cool, but how does it look like for the devs? Because the devs, they don't want to think about the security and encryption and all of those things. They just want to write their code and off it goes. Runs somewhere, don't care where. Right? So what does the developer experience look like? And for this particular example, this particular company, their developers really didn't want to care about infra. And on top of that, they didn't have a very strong platform team either. So everything needed to be super automated and super nicely configured so that everyone can just do their jobs. The way we did it, I mentioned GitHub Actions. So that's what we wrote, like a couple of stages of the CI/CD. This was, mind you, a first iteration of a devex platform. If you're writing a devex platform, it's going to take some time to adjust and to modify it. So, but this was the generation that we made for them. You have 3 steps, 3 events that happen within GitHub. One is pull request open, pull request merged, and tag released. We said that when somebody opens a pull request, nothing will be deployed. We're going to run tests, and we're going to run Helm build and Docker build to make sure that the artifacts are buildable. Once you merge, we're going to deploy to dev. So the artifacts, the code changes are going to be packaged up. The artifacts, the Helm charts, and the Docker images are going to be uploaded to Artifact Registry, the centralized one that I mentioned. We are going to run binary authorization here, saying that this package was built using the pipeline. So here we are ensuring that this is not a rogue package, a rogue artifact that was injected into the deployment pipeline. It has been built using the CI/CD, and we have all of the tests passing and all of the approvals, because you can enforce different teams' approvals with code owners and such in GitHub. And so you can say, OK, compliance team needs to review this particular one. Cool. We can make sure that with this signature, with the binary authorization, we are guaranteeing that it has passed all of those steps. And we tag with the commit hash so that we can link to the specific commit, specific change in the code repository. This is important because, again, tags can be changed, modified, edited, deleted, whatever, but the commit hash always stays there, so you can make sure you can show the auditors where the thing came from. Now, OK, you've deployed to dev. What happens next? You're happy with it. You want to deploy to production. OK, you release a tag. Now we're releasing a tag, OK. But I said that we need to make sure that the image that is deployed into production is the same image that is deployed to dev. So we're not going to build anything in this step. We're going to take the existing Helm chart and the Docker image and write the versions into the production Argo CD manifests. Argo CD is the last link in this chain, being the deployment, the CD, the thing that takes the artifact and makes it run on Kubernetes. So in Argo CD, you have app of apps, which are basically just manifests where you say, this app with this configuration, with this Helm chart, replace these values. Another abstraction on top of everything else. So we're going to just change the Argo definitions for prod and sign the image with production ready. Again, with binary authorization. In this case, we're doing two different attesters. So you can define different attesters in binary authorization for different tasks. In this case, we're saying this image has been built using our CI/CD. OK, cool. And now this image is ready for production. It has passed all of the validations and gates. OK. What you can do is have an attester for the compliance team, have an attester for the legal team, have an attester for whatever else. You can have multiple layers of these attesters and even give the keys to sign to specific people. And then they can generate these cloud artifacts that, again, cannot be tampered with and can be verified at any point in time. We also added a manual approval gate here, because that's important. Finance, again, the CD cannot be absolutely automated. And we deploy to prod. Happy days. There are no change release meetings. Everyone is just relying on really good written tests and a really well-written pipeline. Functionally, the way this whole thing works, the Argo, the binary authorization, the CI/CD, etc., you have top left the Argo CD apps definitions that I mentioned that will say that this application in dev has the target revision version of the Helm chart, blah, 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 blah. You define that revision version. In the artifact registry, you have the Helm chart of this version, and the Helm chart points to a Docker image. The Docker image has a version, which is the git commit hash, but also it has a digest, which is also a hash. And it is by that digest that we're going to be deploying things. So the Helm chart is not actually pointing to a tagged version. It's pointing to an artifact registry hash digest. That's important because, again, tags can be overwritten. Digests cannot. Argo CD runs in the cluster, and it listens to GitHub, and it can pull from artifact registry. binary authorization runs in a separate project. So again, nobody can tamper with it. Nobody can even access these signatures except specified SecOps people. And the project where the Kubernetes cluster runs will verify the signature of the hash of the Docker image with binary authorization. There are testers that this project knows it needs to look at. And I'm going to tell you how to configure that. So this is dev. And the tester that the dev environment cares about is the build time attester, the one that says, this image has been built using our pipeline. Cool. And Kubernetes will then run the application. So there are a couple different parties that take part in this full process, but everything is automated and completely transparent to developers. How is it transparent to developers? Templates. We're using GitHub Actions and Helm charts and Argo CD, so everything can be templated. So we have the deployment pipelines that are templated, and this allows us to write in all of those steps that the developers don't need to care about. We have the complex concepts and infrastructure things, cluster names, attester names, how do you identify yourself to a project, what project to deploy to. All of that is defaulted into the templates. So what the developer needs to do is say, my image is called this. Or maybe they need ingress. They can pull in a template for ingress in Helm chart. You need secrets. We also automated that. Just put your secret names here, and your app will automatically have access to those secrets. It's flexible. It allows the developers to mix and match different templates, yet it's controlled, because the templates are written with the security in mind. And this is like a sample. On the right, you have a sample folder structure where you have GitHub workflows for the 3 steps of the pipeline, the app itself, and the Helm templates. The Helm charts obviously can be modified, but then the pipelines, even if somebody modifies the pipeline, the Kubernetes cluster itself will not allow the artifact to be deployed if it hasn't passed the official pipeline. And the way that is done is by enforcing the binary authorization on the project where the Kubernetes cluster runs. What I mentioned, that the dev environment only cares about the build time attester. And this is how you do that. This is a Terraform resource for binary authorization policy. You have evaluation mode. You can require attestation. The other one would be like an audit kind of enforcement mode. Then will be enforced block and audit log, or you can have just analyze. And the suggestion is, like the recommendation, is that you enable it first in audit only, because then you will see which images are denied and why. Because that's important, because, OK, you're building all of your own apps, but what if you're deploying external secrets or Grafana? You don't want to rebuild all of the images that will be running. Or you're using the Cloud SQL Auth proxy, which is the official Google Cloud tool to authenticate your apps to Cloud SQL. What do you do with that? Well, there are ways to whitelist those images. And by using audit log only at the beginning, you will know which images are getting denied and why. And then once you're ready, you enforce it. OK. And you also list then attesters that are needed. This is where in the dev project, we said build time only, and in the production one, we had 2 different attesters, build time and prod ready. And if you have different attestations for your legal department, compliance, and so on, you just list the attesters here. And this is what prevents images that have not been signed from being deployed. And again, this is all Google Cloud functionality, but it's the exact same thing. These are just admission controls. And if you have a signature that you want to generate using whatever other cryptographic tool, you can enforce that on, there are tools for this for any sort of Kubernetes deployment. But in Google Cloud, you can do this for Kubernetes and for Cloud Run, which is really handy. If you don't want to manage Kubernetes and you just want to run apps, I suggest you use Cloud Run, but you can still have the security. Yay. And this bit is the bit about the whitelisting. What if you run Grafana, Auth proxy, all of those things? It looks like this. So you just list the images and the paths that you need to trust. Of course, you have to have an agreement on that. If you work for an enterprise, they probably will not let you just list whatever images. But at least, like, if you know that you're going to rely on this, and that, you can whitelist those images. And within like Google offerings, you have the mirrored open source registries where you can also rely on the scanning and the vulnerabilities that are known there. What else can you do? Right, so you've enforced all that. Okay, cool. But there is more to the supply chain, right? Software supply chain. So what else exists in the ecosystem? This is, again, all Google Cloud tools, but you can use whatever else from the open source. Starting from left is where you write code, cloud workstations and cloud code, repository, IDE. This is where you plug in vulnerability scanning into the point of writing the code. That's really handy. You can already see that you're using a library that is outdated, for example. Cloud build is, you were using GitHub Actions for that. Artifact registry, whatever registry you have. Most registries right now use and have some sort of vulnerability scanning built in. Artifact registry obviously does. All of your images that are stored in an artifact registry will automatically be scanned against known vulnerability repositories. And you will have a dashboard that points to the CVEs, that points to the resolution patterns. The metadata is stored. Google Cloud Deploy, the Argo CD was doing that. Whatever your Flux2, Flux CD, whatever you're using, this is the point where you need to make sure that that part cannot be tampered with, because what if someone can override that app definition and switch it to something else? Binary authorization, like I said, you can use other products for that as well, but this kind of controls the admission to the Kubernetes engine and the Cloud Run. If you were to run your applications on Google Cloud, you have access to all of these tools. Plus, on Kubernetes, you have container analysis, which is, I love enabling it and showing it to people, because you have a dashboard of your running workloads and their vulnerabilities and their misconfigurations. Have you opened up something to the internet? Is your cluster not as private as you thought? Is some sort of container having extra privileges and things that accessing things that it shouldn't have access to? Is your Kubernetes service account accessing all namespaces when it should have access to only one? Those things. You have it in there by default. Not by default. When you enable container analysis, you have all of that information in container analysis, in a dashboard for Kubernetes security posture. I'm so excited about it, because historically, knowing what's going on in the running environment is tricky. All of the artifact registries, although the image registries, they all have vulnerability scanning generally, but that's the static image. What happens in runtime? What if your image was not vulnerable, but then actually, when it runs, it downloads another package from the internet and becomes vulnerable? How do you know that? That's the runtime analysis. Having that in all of your environments, within whether it's Kubernetes or Cloud Run, priceless, honestly. So I really like that. And if you're using Google Cloud and Kubernetes, do enable that. It's really cool. And once you do that, you really control all of the stages of your software. So you're writing things, you're scanning the code, you're scanning the artifacts, you're signing the images that are being built, you're not letting unsigned images in. All of the different steps of the software supply chain that can be injected, you are working to prevent that. And you can automate all of it, thanks to the tools that exist. And that's all from me. Thank you for your attention. You can stay in touch with me on the right, and yes, you're right. And please leave feedback on Open Feedback, which is the QR code on the left. Thank you.